we go.
Hmm.
Yeah, I need to pull images. I haven't pulled images because I was talking to lovely you. There's a jet picture. Let me add you to this scene. There's Fraser. So folks, what we were talking about was the new Macs that came out while we were recording last week, and I have a Power Mac that I just paid off. That is the studio computer. And it just hurts the soul that a new computer came out at a third the cost that is about the same abilities, functionalities. And so there's also going to have to be that long-term strategy of how do I upgrade my systems. And right now I have one of those extremely heavy Mac i9 laptops. And so the question becomes, what order do I upgrade systems? And the studio computer is not getting upgraded until it no longer does its job because it has all the ports it needs.
Yeah, no, it's good. It's a good machine.
Our water pump is like going and going and going. I'm wondering if my husband made the mistake of deciding to take a shower. We may have to just go with the water pump.
I don't hear it, but maybe the audience hears it.
I know the audio picks it up. Okay, let me get 2 pictures of jets and then I'll be ready to go. So, yeah. So anything good going on in your corner of the universe?
We have a cistern for our well, which is kind of cool.
Yes.
Yeah. That's so the thing about getting a cistern is that when you put it into the ground, you have a big hole and you put this giant concrete box in the hole. And then if it rains, then the hole fills up with water. And the concrete box will float.
Oh, that's bad.
And so super bad. Yeah. And so a lot of people have this problem that they install a cistern for some reason and it floats and pops out of the ground. And so people can have like a brand new septic field that they've installed, and then heavy rainstorm happens, and suddenly, because the ground is kind of holding on to the cistern, and yet the water pressure is pushing it up, and then suddenly, pow, the cistern will launch out of the ground and just at like whatever shape is most stable. And so you have this like a breaching whale. You get a cistern popping up in your landscape. So anyway, this is like the number one fear of anybody in this industry. It's all they talk about. And so solution is that you fill water.
Okay.
You fill the cistern with a bunch of water. Weird.
What's wrong?
I added a picture and it's very weird.
All right.
Huh. Okay. All right. Yeah. And so I'm pumping out the hole that's filled with water. I'm running the well to fill the cistern with water from the well. But the whole reason we have the cistern is because we can't run the well very long or we'll burn out the pump. And so I have to watch the well as it goes. And then the moment it starts to get kind of fizzy and airy, it means it's sucking air. Then I have to shut the well down and let it recharge while I'm pumping out the hole. Anyway, it's a thing.
This is far more like, I know leach field issues in New England were always a problem because the freeze thaw cycle will bring boulders into your leach field and destroy it.
Yeah.
But I hadn't realized all these other issues that you're going into. Good Lord.
Oh yeah. And so it's all just preventative, right? It's all just to avoid the dark possibility of it popping up, and then you have to literally pump the whole thing out, bring in the excavator, clear out the space around it, bring in a truck that's capable of carrying the thing. There's not very many of them. Move it out of the way, rebuild the hole, put it anyway. It's a thing. So so instead, every 3 or 4 hours, depending on the amount of rain that's happening, I go up there and pump the water, and yeah, it's just. But once I've got it filled enough, then it should be safe.
Yeah.
About 2/3 full, it should be safe.
Yeah.
Okay.
Okay.
So just so people know, Pamela's got a book right after this episode, so we won't have time for questions.
Yeah, I have reached the point in life where I need to get reading glasses. I'm not okay with this.
I need to do the same. Yeah, I got to go and get my prescription for reading glasses, because I am definitely not able to read things up close anymore.
I thought mistakenly that I could do the just go to the. I almost have this set up to show you pretty pictures, folks. I thought that I could do the standard go to the drugstore and just buy some off the shelf. But what I learned is my left and right eye are in no ways similar to one another in functionality.
So you're going to need a prescription, a proper prescription.
Yeah.
Yeah, I don't know. I think my right eye is better than my left eye. All right. Let me know when you're ready.
Opening audition, and then I'm ready. We have pretty pictures. Adobe Audition. I need to sit back or I chop off my own head. There's the window. Do you find yourself playing? Which window does it open on this time?
No.
Okay. I guess that's just a me thing.
That's a Mac thing, I think. I'm still running Windows.
Silly human.
Not for too much long. I mean, I use my MacBook as my most of the time, but I still run my Windows machine as my streaming machine. So.
Okay. I am ready to do this thing if you are ready to do this thing.
I'm ready.
I lost my mouse. There's my mouse. Okay. Now I am ready. I am pressing record.
I have also pressed record.
All the recordings are, yes.
Okay. Astronomy Cast, episode 635, Astronomical Jets. Welcome to Astronomy Cast, our weekly fact-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. How are you doing?
Also well. Sort of dealing with the trials and tribulations of getting our house completed. We're in the final stretch now, and so it's all the little details that need to be done perfectly. Each one can hold up the thing, and yeah, but we're getting there. All right, so astronomers look out across the universe. They see various objects spewing jets.
That's a new word.
As astronomers look out across the universe, they see various objects spewing jets of material light years into space. What causes these jets, and what impact do they have on the universe? And we'll get to that in a second, but it's time for a break. And we're back. All right, jets. Now, we're not talking about like aircraft jets.
No.
We're talking about space jets.
Yes.
But they're not aircraft jets in space.
No.
What is a jet?
So at the most simplistic level, a jet is any time you have something that sends out materials at high velocities. So when we call an airplane a jet, what we're actually referring to is its engines that are spewing material out at high velocities instead of just having a propeller at the front.
And throwing an airplane in the opposite direction.
Exactly. Right. Now, in astrophysical situations, we are talking about situations where you have some sort of an object that has an entire environment around it that is leading up to it sitting at the center of normally bipolar, going out in two different direction jets that have been built up most typically by a magnetic field.
So, like, I guess think of a fountain,
Yes.
like a fountain throwing water high up in the air. The distance that the fountain goes is limited by the force of gravity, so it reaches sort of a maximum height. It's running into the air, and so you're getting both the jet getting a little bit slowed down, but also sort of broken apart a little bit, as well as other spray and material going off in all directions. Except with the astronomical ones, they go in two directions. So you'll get jets in as you say in polar directions.
And the gravity of the object can, if it doesn't make it very far away, cause the material to flow back at you. But most of the time, as the material is getting kicked out at such high velocities, you don't really see this. We refer to it as collimated, the getting tightened into a focused beam. We don't see that focused beam start to diffuse out into a cloud of material like at the top of a fountain until it hits that interstellar media, until it hits all the stuff that is just filling space between galaxies or between stars.
Right. I guess, I mean, there's not that much to run into.
Depends on the system.
Yeah. So what can generate these jets? What is their cause?
The bulk of the time, it is extremely complex physics where the correct answer is we don't entirely know. The answer to
But you can't just say extremely complex. The answer is extremely complex physics. Like that is unsatisfying to me.
I know. And this is why in introductory textbooks and magazine articles, all that complicated physics gets hidden behind the phrase magnetic fields.
Perfect. Now we're talking. It's magnets.
And the truth is, there are magnetic fields that are involved where you have, with the majority of these systems, you have some sort of a disk. And as that disk rotates around your central object, it gets hot. The material gets smashed together, causing heat through density. And I'm going to sneeze. Sorry about that. Okay, so you have this compact object that has material spiraling around it, and it's often getting either stolen off of another object or it's flowing into the center of a galaxy. And as it comes in, it is getting denser and denser and denser because the material has to shed angular momentum in order to get in towards the center. So it backs up while it's going through this process of shedding angular momentum. And this built up material gets denser and it gets hotter due to that Pervnerd equation that we learned in high school chemistry, pressure, density, temperature, all related things. And if it gets hot enough, it can even start having nuclear reactions. So hot gas, it's going to eventually become hot ionized gas. And hot ionized gas means you have atoms that have shed electrons away, and these are now charged objects. Charged objects orbiting are charged objects going in a circle. Moving charged objects create magnetic fields. Moving charged objects going in a circle create basically electromagnetic fields like a battery and some wire can do. And you've now built a very small railgun that can fling things out of the magnetic field along these polar axes.
All right. So you've got matter moving at high speed, crushed together, heated up to enormous temperatures, starting to undergo more exotic processes like fusion, but ionization of these particles. They're moving in circles around whatever object they're orbiting. This is generating electricity, magnetic fields, and complex physics, like just that soup of
Yes.
madness, is now creating this, as you call it, a Gauss gun, a rail gun,
Yes.
a magnetic accelerator that is
Yes.
then taking this raw material and hurling it away from the accretion disk.
And what I
All right.
love is at the most simplistic level, this is something you can do with a sixth grader, wire, batteries, and a tiny magnet. So go figure this out for yourselves, people.
And
It's
feeding material from a binary companion star,
well, yeah,
generating nuclear
yeah, yeah,
fusion.
yeah,
Yeah. I mean, any sixth grader can do this. All right, we're going to get more into this in a second, but it's time for another break.
I'm gonna switch views.
And we're back.
Hold on. Ah, I'm switching views. Now we're back.
All right, so we've got a sense of what is the underlying complex physics, or at least the ingredients of the mess that is happening. And I think you said it perfectly. Like astronomers still don't know. Some of the finest minds in nuclear physics, in particle physics, in magnetic fields, in fluid dynamics, in all of these fields working together, are still arguing and discussing and running. So like
Let me give you one example.
Also, relativity has effect as well. So
frame dragging.
Yeah.
Frame dragging
Yeah.
is a thing. And to give you one example of why this is confusing. If you go back to your sixth grader model of literally, you can do this. Go grab some wire that isn't insulated the way this is, wrap it in a circle, attach both ends of the wire to a battery, and now you have charge flowing, and you can use this to fling small objects. It's fun if you get big and fancy. Car battery, PVC wrapped in wire. Now you have a small railgun. Now, when you build your small railgun, it is always going to fling magnets in the same orientation. With galaxies, you have electrons getting thrown both directions out of this. And so you have to build up a system that allows symmetrical flinging of materials in both ways. Now, electrons have both not positive, negative. They have both north and south magnetic orientations. So you can, there's ways to get there, but just understanding it is flinging things in a symmetric manner is kind of like where you get at this is hard.
But it's perpendicular to the axis of rotation of the object. So if the galaxy is rotating, right-hand rule, you're going to see material blasting up out of the center of the galaxy and also down out of the center of the galaxy in completely opposite directions of the galaxy. All right. So we know, again, I guess I say, like, we know why this is happening. We don't know why this is happening. All we know is that in that mess of complicated physics, this is happening. What kinds of objects are capable of generating these jets?
Okay, at the most pathetic level, we have very young stars called T-Tauri stars. The bulk of a T-Tauri star's jets are due to outflows of just, it's not eating the material fast enough as it flows down onto the star and things escape. But it also, its magnetic fields will bloop out material in pockets now and then. So you have ineffective bloopy jets coming from T-Tauri stars. Then skip through most of the stars in between that are happily doing their main sequence and beyond life of nuclear fusion in their core. And then we get to the neutron stars. So as soon as you get to something as dense as a neutron star, these objects become capable of gravitationally pulling stuff off of a companion and getting it going fast enough around the neutron star because it has enough gravity and it's tiny enough, and you need both, that you can start getting that jet that has the magnetic field again. So for individual objects that have long-term lasting jets, you have T-Tauri stars, Herbig-Haro objects at the very beginning, things forming stars. Stars are happy, stars are happy, stars are happy, stars die. And for dead stars, you have neutron stars and bigger. And when I say and bigger, I mean like all black holes all the way up to supermassive black holes are capable of having
Hmm.
jets. So you can have a full-fledged galaxy that has the exact same, not entirely well understood physics as that neutron star.
It's just a matter of scale.
Yes.
Right. All right. We're going to talk about this matter of scale in a second, but it's time for a break.
Going to switch views again, switching views again, switching views again. Hold on. Okay.
And we're back. All right. So let's talk about scale then. We talked about how like a neutron star will generate some level of jets, and supermassive black holes, the most massive objects in the universe, will generate these jets. What is the scale? How far out can these jets go from their source?
Light years and light years and light years and light years, by which I mean we're talking thousands and thousands and thousands of light years from the center of a galaxy. In the image that those of you who happen to be watching on YouTube or live while we're recording on Twitch, there is a tiny speck that on my particular monitor is the size of my pinky fingernail that represents where the galaxy is. And about 7 inches away in this image is where the jet ends. And the jet is actually pointed a bit at us. So that's hiding some of the full length of this jet. In the radio sky, galaxies are a very different size than they are in the optical sky because of how big these jets are.
So for like a neutron star, we're talking dozens of light years.
It can be.
Yeah.
Now the neat thing about neutron stars and stuff is they exist in much more complicated parts of our galaxy. So their size is going to be beautifully dependent on how much stuff is around them. And so we can end up with they go out and now they're pushing their way out, blowing a bubble around them. And it's this blowing a bubble around them that at a certain degree allows us to figure out how long they've been doing things in some cases. And
Because you know how fast the material is moving, and then that lets
yeah,
you figure out when it started this process. Okay.
yeah. And so you're looking at different kinds of environments, but what is particularly fascinating is when we look back at the center of our galaxy, even from where we are, in the correct wavelengths of light, we see all these bubbles all over the place. Some of them are spherical bubbles that are created by supernova explosions, but in other cases, what we're seeing is the material pushed out by jets.
Huh. That's really fascinating that, you look at the universe in these different wavelengths, and now you see this historical record of the events. You see bubbles blown out from ancient supernovae. You see the wakes of jets released by neutron stars while they were actively feeding on some companion star, or black holes while they were feeding on some companion star. And I'm guessing we see something similar for galaxies with active nuclei, that we can see how things have changed over time with them.
I'm not sure we've actually seen something like that, but it could be I've missed it in the literature. But
There was a paper that I recall where they were seeing the material falling back in, or they were seeing like light echoes
so
from
light
the
echoes
jet.
we see, yes.
Yeah, they were seeing light echoes from the jet that was telling them that they allowed them to figure out when it was an active galaxy, and it's
Yeah.
not an active galaxy right now.
So
And that would be
light echoes are fairly common-ish in the grand scheme of we've seen more than 3 now. I've been in astronomy
yeah.
long enough that anytime you see more than 3, that's awesome. Um, But in terms of just seeing a galaxy clear out the world around it and no longer be doing that, that's what I'm not sure we've seen. So we've
Right,
seen the
right.
light echoing.
Yeah.
But what's awesome to me, and what I can't wait for us to see the relics of, is supernova explosions in just the right format, specifically gamma ray bursts. They have the shock wave going out in a sphere that may be interrupted by planetary disks and things, but generally going out in a sphere or bipolar outflows that is caused by the star itself exploding. But what we're now starting to think is, in some cases, when you have a nearby companion, this material that's getting shot off can quickly spin up in a disk as it gets to the companion, creating this gamma ray burst. That's only one of several explanations of a gamma ray burst. It's the one I like the best.
Right. Yeah.
Whatever the source of these gamma ray bursts is, you end up with these tremendous high energy jets that last very briefly and are capable, we think, of destroying planets several hundred light years away.
Several tens of thousands.
Is it
It will cause
7,000 or
damage.
700? It will cause damage.
Yeah, it'll cause damage. So yeah, if it's a few hundred light years away, it'll just like it'll destroy planets.
Yeah,
But
you
even
have
if you're
roasted rock left behind.
right, but even if you're halfway across the galaxy, you
Ionizing
will have your
radiation.
ozone. Yeah, the ionizing radiation will blast away your ozone layer, and everybody will get cancer and die. So,
But the planet will recover. We believe we have
right,
experienced that in our past. The world is still here. Within a few
yeah,
hundred, you basically have Mercury left behind.
yeah. And good news, there are no
We're safe.
stars capable of going gamma ray burst in our vicinity that we know of.
Yes.
All right, so you talked about like one impact of a gamma ray burst, but with jets. But what influence, what effect do these jets have on their galaxies and the areas surrounding them?
So you clearly don't want to get into one of them because they're a source of ionizing radiation. They are giving off loud radio signals, so communications near them is certainly going to be difficult. But in general, it's that disk that is generating them that I'd be afraid of. Because that is giving off a truly amazing amount of light in the center of a galaxy. The jet is going out of the galaxy, so you can sit there and go, oh, beautiful. But that accretion disk in the galaxy you're living in that is generating this disk for supermassive black hole ones, there's another word for that disk. That's a quasi-stellar object.
Quasar.
Yeah.
Yeah.
And so the light from that has the potential to be dangerous to fairly large distances within the galaxy it's in.
So I did research into this,
Uh-huh.
and if the sun turned into if the supermassive black hole at the heart of the Milky Way turned into a quasar, you wouldn't see it with the unaided eye. You would need a very powerful telescope to even detect it. It's because you wouldn't be staring down the throat of it the way we are with a lot of other ones, right? To see it from the side, it actually wouldn't be significantly brighter. But I guess what I'm getting at is you've got this jet of material that's flying out kind of like a fountain, back to that original analogy. And then this material is falling back down into the galaxy in some cases. What influence does that have on the galaxy?
I have no idea.
Star formation.
Thank you.
Causes star formation.
Okay. I did not know.
Yeah, it's believed that it creates star formation.
Okay, so we'll go with that. And
sure.
Sorry, Rich, you're gonna have to edit my ignorance out. So the material coming back, just like anytime you get a shock wave, it can trigger nice, happily sitting around molecular clouds to collapse down and possibly form stars. And I just want to go back to what you said. Yes, with your eye, all the dust in our Milky Way is going to hide that accretion disk from us. The trickstery bit gets to be, there are other wavelengths of light that you're going to have blinding light for other instruments coming out. And this is where the sky, again, is so different, radio versus optical.
And there was another piece of research that I saw, and I don't know if you had seen this one, that a galaxy had gotten hit by the jet from another galaxy, another nearby galaxy.
No.
And they think that it might even cause the, in some cases, maybe cause an increase in star formation, but maybe even quenching star formation,
So
which was quite fascinating.
if you blast apart areas that are forming dust, then you've added enough material in, you've added other stuff in, not material, you've added enough energy in that instead of the material collapsing, the material is going to dissipate in the face of this wind, just like blowing out. You shouldn't smoke, people. You should not smoke.
Right.
But if you imagine exhaling smoke, you have a nice little cloud here, but on a windy day, you never get the cloud of smoke.
Right.
Let's go with a cold day. You exhale your breath. If there's no wind, you can see your breath, but if there's a lot of wind, you have no chance to see your breath.
And you need a nice cold cloud of gas to form a star.
Exactly.
If energy is getting pumped into it, it's heating up.
It can't collapse.
It can't collapse. You might have the other problem. But the other thing that's interesting as well is that these jets may provide, because you've got fusion going on in some of the cases of these, you've got heavier elements that are actually being generated and thrown out into space. And so it might actually be another source for heavier elements that contribute and enrich to some of these solar nebula. So it's a field that is really wide open for discovery, both their underlying cause as well as their influence and their effect. It could be everywhere from no effect to life might not exist without these jets. So more research is needed.
And just, you can track the history of stellar vampirism. So while we may not have vampires on our planet, there are vampires among the stars. And if they aren't continually sucking at their neighbors, they will have puffy jets. So I'm just going to leave you with that thought that there are puffy jets of non-continuous feeders out there.
Very cool. All right. Thanks, Pamela.
Okay. Thank you, Fraser. And it's time for me to do that thing where we thank all the amazing humans out there that make this show possible. Every time I say, I'm sorry, Rich, you're going to have to edit. Well, it's because of these people that we can pay Rich and Allie and Beth and the whole team of people. Oh my goodness, Nancy, thank you for keeping us lined up. This week, I want to thank Jeremy Kerwin, Rob Cuff, Harold Bardenhagen, Alex Cohen, Rando, David Gates, Marco Arasi, Nikki Lynch, Daniel Loosely, Philip Walker, Scott Beaver, Brian P. Cox, David, Matthew Hortson, Matthias Hayden, Justin Proctor, Disastrina, Gregory Singleton, Niall Bruce, The Lonely Sand Person, Jim Schooler, Jeff Wilson, Tim McMacken, Paul Hayden Cooper, Nate Detweiler, Aaron Zegriv, Elon Mon, Benjamin Mueller, Stephen Shewalter, Omar Del Riviero, Kenneth Ryan, Karthik Vekatraman, Alex Rain, Paul D. Disney, Michael Regan, Don Mundus, and Dean McDaniel. And Rob Cuff, thank you for giving me a pronunciation guide for your name. And thank you so much to all of you. If you too wish to have me vaguely pronounce your name correctly in one of our episodes, I'm so sorry. Please join us on Patreon. If you would like your name pronounced correctly, add a pronunciation guide.
Wonderful.
Thank you.
Right. Thanks, Pamela. We'll see you next week.
Bye-bye. All right, and now they save.
All right, and you got to go. So why don't we wrap this up?
Okay. Seriously, message me your questions. Any of the rest of you out there, message me your questions, and I will get to them. I just need to go get glasses first.
Go get your glasses. All right.
All right.
Thanks, everyone. Open space tonight at 5 o'clock. So if you want to come back in about 5.5 hours, I'll be here. All right.
Sounds awesome. Okay.
All right. Thanks, everyone. See you later.
Okay. Bye-bye. Buttons, looking for buttons. Sorry.